Can you tell me the topic?
Yes, sir. Equilibrium.
Equilibrium. I have to start the equilibrium.
Equilibrium.
We have covered the case of perpendicular.
Yes, sir. We wrote the definition of equilibrium like force on the point charge, point mass is zero. That is equilibrium. You told that if there's a ball and both has the size is 2 and 20 and 20, and so then F net will be zero because the ball won't move. That much for equilibrium.
Okay. So we have completed this. Like we have completed this. Like we have two vectors, like A vector and B vector, 90-degree angle, and resultant is A square by B square plus B square. Till here we have completed. Okay. And also we have completed the equilibrium.
We started it. We wrote the definition.
Okay, very good. So Bhumi, can you do you have any idea about the equilibrium?
Yeah, it's the stable state, like
Yeah,
achieving
very
the
good.
stability.
Very good. Do you have chemistry also?
Chemistry? Yes, we studied in equilibrium in chemistry as well.
Yeah, good. And along with chemistry, do you have biology or mathematics?
Biology.
Okay, biology. So, physics is very important for you, and because you are a student of biology, so you will not study the concepts of maths. Okay, but in physics we will use we will use the concepts of math. So
Yes.
no problem, I will explain each and everything, but try to focus only, because
Yes.
generally I see that the students of biology feel difficulty in physics. This
Yeah,
is my
then
this is my opinion. Okay, no problem, but we can deal with it. So equilibrium means the stability. You have said right. What is stability now? Suppose here is a ball and someone is applying a 5 Newton force in this direction, and another one is applying the force in the same direction of 10 Newton. Okay, so as we have already discussed, two vectors are these are the two these this is the case of two parallel vectors now.
yes. So it will be zero because it's parallel, so it will cut.
Like this you can see here. Okay, I do not have that portion. So like parallel vector means these two vectors 5 Newton and 10 Newtons are in the same direction.
Yes.
10 Newton. So if I want to calculate the resultant force, so what will I do? I will add them now. I have told
Yes.
you, when two vectors, like this is a force in this direction, and 1 minute. Okay, now let's see. This is a force in one direction. Someone is applying the force in this direction, and another one is also applying the force in this direction. So the net force will be the sum of two forces. Like you can see here, practically you can see this is one. and
Yes.
I am applying one force like this, and now I am applying two forces like this. Means this phone will move like this, and
Yes.
and if suppose this is a copy, okay, why this copy is at rest?
Because the forces are applied from
In
different
opposite
sides.
direction.
Yes.
Means this is in rest because the forces are in opposite direction and they are cancelling each other. Means the net force on the body is zero. So equilibrium is nothing but when the net force on the body is zero, we can say the body is in equilibrium.
Equilibrium state. Yes.
Sorry. Okay. Now equilibrium means force net force on the body, or you can say a point charge. If you are taking a charge, so you will say net
Point
force on
charge.
the charge. Net force on the body is zero. So this is the first case. Here the net force is not zero, means net force is 10 plus 5, 15 Newton. Means this body will not be in equilibrium.
Because it's
Suppose
gonna
this,
move.
very good. Because it will move, and you can see this physically also. This will not be in stable condition. What is the meaning of stability? Stability means like we are stable, we are sitting and we are at rest. Okay, this is stable. So here I will say body A not in, I am writing equilibrium as this. Okay, so why not in equilibrium? Because the net force on this body is not zero. Now I am taking another body, not another body, I am taking the same body. This is the same body A, and someone is applying the 5 Newton here in this direction, and someone another is applying the 5 Newton here. So this is the case of two anti-parallel vectors. Means two vectors are anti-parallel. Two vectors are anti-parallel as we have discussed in the previous classes. So when two vectors are anti-parallel and we want to calculate the resultant force, so what will you do? I want to calculate the net force on the body. We will subtract them.
Yes.
This will be 0 Newton. Means the net force on the body is 0. So we can say this body B in equilibrium. So that's why we have studied vector, because here is a requirement of vectors. When two forces are acting in the same direction, like here two vectors in same direction, na, angle between them is 0. So we can directly add the vectors to find the resultant. And here two vectors are acting in opposite direction. This is the opposite direction, na?
Yes.
And this
Anti-parallel.
is also the opposite direction. Suppose for the same body, if I have told you that this is the body and this is the force like this. Here is a force and here is a force. This is 5 Newton force, this is 5 Newton force. And again net force will be 0, na? Because again these vectors are anti-parallel. Okay. So this is the condition of equilibrium. Means you can say the force is 0 on the charge or body.
Yes.
Okay. So please note it down from here. Should I scroll down?
Yes, sir.
Fine.
Yes, sir.
Okay. Now, why we are studying this, you will get to know when we will solve the next question. Why we have done all these things, these vectors and all that.
Whenever it is parallel, you add, and when it's anti-parallel, you subtract. So basically, anti-parallels are the one which are in equilibrium.
No. Let me explain. Very good question. Like, here is a body, and suppose someone is applying a force of 5 Newton and another is applying a force of 10 Newton. These are anti-parallel now?
Yes.
Okay, so I want to calculate the net force. So I will subtract 10 minus 5 will be 5 Newton. So here you can see now.
Yeah,
Here
it's
you
not
can see
zero.
here the vectors are anti-parallel, but the net force is not zero. So this body will not be in equilibrium. So this is not the case. So
It depends on the value of the
yeah,
movement.
if two vectors are anti-parallel, if and only if the body will be in equilibrium when they are equal.
Yes.
When they are equal. Okay. Very good point.
Yes, sir.
So here I can write body C not in equilibrium. There is one and only condition of equilibrium here at this point of time that we are studying. Net force on the body or a charge is zero. If net force on the body or a charge is zero, then the charge will be in equilibrium or body will be in equilibrium. Simple. Okay. So we have next question. Do you have any programming language also in your syllabus?
No, sir.
Okay. Two charges plus E and plus 4E are placed at separation A. At what point on the line joining the two charges you are in 12th or 11th?
12th.
You are in 12th. Okay.
Yes.
Two charges. Line joining the two charges. A charge Q is placed. A charge Q is placed so that so that charge Q is in equilibrium. So now we will see the whole of the story that we have studied earlier. So please look at the question carefully. Here are two charges, plus E and plus 4E, and they are positive charges. Okay.
Yes, and the
And
distances are A because
very
it's
good,
separated by A.
very good, very good. And this is a line joining between the two charges now. And here
Yes,
is a charge plus
plus
E
E
is placed, and here is
plus
plus 4
4E
E is placed, and the distance between these two
is A.
is A. Here there is no problem till here. Okay. Okay. Distance is A.
So we have to find in on this line where the charge Q is placed so that the Q becomes an equilibrium.
Equilibrium means the force on
Yeah,
that charge should be zero.
yeah,
So I can write charge here also, I can write charge here also, I can write charge here also. So there is
yes.
a problem. There is a problem. So if there is a problem, then there should be a solution. So what is the solution? Suppose I am. So where? Tell me, where do you want to place that charge?
Charge Q.
Yeah. On this line, you have to put the charge on this line, and according to your wish, I will place that charge. Where do you want to place that charge? In between these two charges, here and here.
In between.
Okay. Suppose I am placing the charge, this charge Q. This is also a positive charge, okay?
Yes.
Here Q at a distance of x. Suppose this is x, let. At a distance of x from this charge, okay? And this whole
Yes.
distance is A. This whole distance is A. Then what will be this distance?
This distance will be A minus X.
Very good. Very good. This distance is A. So this distance will be A minus X. This is X. Okay. And this distance, whole distance is A. Now, what I am going to do means force on this charge. Here, this is written here. Q is in equilibrium. It means that the net force on the charge Q should be 0. Okay. So we will calculate the net force on this charge. So net force on this charge will be due to this charge and will be due to this charge. There are only two forces. Like if I am there is one force. There is one force here. Due to this charge, the force on this charge will be in this direction, na?
Yes.
This is F1. If I am supposing this charge as one charge 1, and this is charge 2. In this direction, because positive repel,
Yes.
and if due to this charge, the force on this charge will be in this direction. Okay,
Yes.
this is F2. So what I have told you that this is a charge Q and here is a force F1, here is a force F2. What will happen if charge Q is in equilibrium? As I have discussed earlier, means net force on this charge is zero,
Yes.
as charge Q is in equilibrium. This is equilibrium, okay? Means net force on charge Q is zero. So how I will calculate the net of this? I want to calculate the net force on
Yes.
charge Q. So what, they are two vectors and they are two anti-parallel vectors. Okay,
Yes.
they are two anti-parallel vectors, and for calculating the resultant of two anti-parallel vectors, what we will do, what we have done earlier,
Minus.
yeah, we will subtract directly F1 minus F2 or F2 minus F1, and this net force is equal to zero now.
Yes.
See here, net force on the charge is zero. So this value, you will put this value as zero. So what we have? We have F1 minus F2 equal to zero now. So it means F1 equal to F2. As we have F1 is equal to F2. And what I have said here, the body will be in equilibrium only and only if two forces are anti-parallel and equal. Okay, see here, now see here, body is in equilibrium means charge Q is in equilibrium, two forces are anti-parallel and equal. Is it fine?
Yes.
Okay, so I want to calculate F1. What is F1? F1 is the force in between this charge and this charge Q.
Yes.
We have the formula K Q1 Q2 by distance between two charges. So please tell me what will be the value of F1. Like you can say, here is E and this distance is X and here is Q. Like this, na? Here, this is na?
Yes.
Okay. So what will be the force? What will be the force on charge Q? By the Coulomb's law.
Q1. Sorry.
K,
Q1. Q2.
very good. K, what is Q1? Q1 is E and this is Q2, Q.
Q.
And what is the separation between them? X
X square.
means X square.
Because the
And
distance is X.
okay, yeah. And now here is a charge Q and here is another charge 4E. And this distance is A minus X. So I want to write F2. Please tell me what should I write here? K,
K.
huh?
Um. K. Q.
Q and 4E.
Yes. By X. A minus X square.
But these two forces are equal means F1 equal to F2. We have proved here.
Yes. We have to prove it.
Yeah. So we will put F1 equal to F2 means this value will be equal to this
The
value.
other value. Yes.
So I will write KEQ divided by X square. This will be KQ into 4E divided by a minus x square. Now the game is over. Gone. This also cancel out. This e is also cancel out. What we have now? What we have now? Here is 1. Here is x square.
Equal to
Here is 4 only.
4 by a minus x square.
Yeah.
You just cancel the numerators, right?
Yeah.
Okay.
And what if I will take the square root of both this? What is the result? What will this become? Taking square roots on both sides. Like square root, you can say this is sorry, this is 4. I am taking a square root of 4. What will be the answer? Do you know?
Yeah.
Tell, please tell. 2 na?
Just yes.
And like for 9 it will be
3.
okay.
3.
So like this now we are taking square root of this on both sides, like here. What I am doing, I am
1
taking
by x square
yeah,
equal to root. So for that it's gonna be 2.
yeah. 1 by x square, the square root of 1 by x square means 1 by x.
1 by x
And here
equal
square root
to
of 4, 2.
2 by
And this will be a minus x
a
square, means
minus
square
x.
will a minus x. And now you can cross multiply these. This a minus x equal to 2x. Okay. And here a equal to what will be here?
2x plus
X.
n.
This is x.
Okay, yeah,
Actually,
2x plus x.
actually I cannot make x. I don't know why, but I make x like this. I have tried many times, but you should be comfortable.
Yes, so it's 2x plus x.
Means 3x.
Yes,
A equal to
3x.
3x. And what will the value of x equal to a by 3? And this is our
So
answer.
that's the distance, both the distance.
Yeah. So we have to put the charge q at a distance a by x, at a distance a by 3 from plus e charge. Okay. So what is the question? The question is that what is the position of charge to put in between these two charges so that the net force on the charge is 0. So our answer is the charge should be placed at a distance of a by 3 from the charge plus e. As we can see here, this is x. Okay.
Yes.
Now, so this is our required answer. So
That
x
should be the
equal to a by
distance.
from plus e charge. Okay, that's fine. And if someone is asking the distance from plus 4e charge, then what will be the distance of this charge?
4e2.
Like I am writing here. From distance of charge q from plus 4e charge. We have the distance now from plus 4e charge. This is the distance a minus x.
A minus x.
A minus X. We have A. What is the value of X? A by 3.
Yes.
And this will become 2A by 3. Okay.
Yes.
Please note it down
Yes, sir. I did till the diagram.
till the diagram. Means
Yes.
you want to note from here.
Yes.
Okay.
Yes, sir. You can scroll.
Okay.
Yes, so you can scroll till taking square root on both sides.
Okay. This is X. Okay.
Yes, certain.
Done now. So after that, mm, now suppose if someone told me that this is the plus E charge and this is plus 4E charge and this is the line joining between. Line joining is very important here because the force acts along the line by joining the charge. And if someone said put the charge Q here, put the charge Q here, and if I have kept the charge Q there, then if I want to calculate the force, if I want to calculate the force due to this charge, what will be the direction? This direction,
Yes.
F1, this is 1, this is 2. And now due to this charge, what will be the direction of force? Again in this direction.
Yes, sir.
So F2 will also in this direction. Means here can equilibrium be achieved? Here, what is
No.
happening here? Two forces F1 and F2, they are parallel. They are parallel, na?
Yes.
They are like this. They are like this. Okay, you can. They are acting in the same direction. This force is in the same direction. This force is also in same direction. Means the net force will never be zero. Net force will never be zero. Means if I place the charge here, no equilibrium of charge will be achieved. F net will be F1 plus F2. This will never be zero. Okay.
Yes.
So this is a concept that I have kept the charge in the middle, and same is the case here. See here, due to this charge, what will be the direction of force? F1. And due to this charge, this is positive and this is positive. What will be the direction of force? This is F1, this is F2. Here also F net will not equal to zero, never equal to zero. So if the force on the charge Q will never equal to zero, will the charge come in equilibrium? Never, na?
No. No.
So that's why we have placed the charge Q here, like here F1, like here F2. Okay. So this is the question on the equilibrium. Equilibrium means the force on the charge must be zero, net force.
Yes. So this basically, so this you said that the charges in parallel can never have zero, so they won't have equilibrium. I mean, they
Yeah.
won't attain equilibrium.
Okay. We will discuss this also. Our next topic is types of equilibrium.
Equilibrium.
So there are three types of equilibrium in this world. Number one is stable equilibrium. Stable equilibrium. Another is unstable.
Stable equilibrium.
And third type of equilibrium is known as neutral equilibrium. Neutral equilibrium. So in stable equilibrium, number one is net force equal to zero on the body or on the charge. And another point is body will regain its original position. You can see here. Suppose here is a bowl like this, and here this is a bowl, B-O-W-L, bowl, and here is a ball. What is this? This is ball. And if somehow you push this ball till here, means you have kept this ball here, what will happen? This will regain its position. The ball will try to regain its position. You can imagine this. Without the imagination, this is not possible to explain. Suppose like there is a ball and you have kept kept that ball there, and now what is happening? The ball is moving downwards automatically. So means that ball is at here is this is the stable equilibrium. This is the stable equilibrium position. Means if you displace this ball, like here you have displaced, this ball will regain its original position. Try to regain its original position.
Yes. It moves. It's due to friction.
Due to friction.
Yes.
This is friction. Very good. This is not friction.
Yeah, frictional force.
Actually, I have considered here this surface as a smooth surface. No friction is involved here.
Okay.
Okay, that's fine.
So in the stable, it will try to regain its original position. So like it will move and like gradually
Yeah.
it will come there in the center.
Yeah. It will move like this. You can imagine this is a ball.
Yeah, it's
Here
gonna
is a
move.
ball.
Yeah.
When you take up the ball like this, and after that, what will happen?
It's
Due
gonna
to the
move.
force, of gravity. Actually, I am not going in deep. Actually, there is deep here. Here is a if I am going the mechanics of this question, means here will be the mg, and the component of mg here will try. That is another topic we will
Yeah, it's
discuss.
gravitational force, right?
Yeah.
Yeah.
Why it is
So
happening? That is a part of mechanics, but you should have an idea. So you
yes.
can imagine the ball will try to come is its original position.
Yes. And unstable is just opposite.
Unstable is just suppose, let's see. Here also the net force is zero. Here
Because it's in
all,
equilibrium.
yeah, because it is an equilibrium, means net
It's
force
gonna
is
be
zero.
zero always.
And second point is body will not regain its shape. Regain, not shape, its position. And I am giving a beautiful example. Suppose this is some surface. This is some surface, and if here I place a ball and now displace this ball, what will happen? Will it regain its original position or never regain its original position?
It won't, because
It
it
won't,
can't
na?
go backwards.
Yeah. So this is the case of this will come somewhere here. Okay, this is called as this ball is in here. This ball is in at unstable equilibrium. This is means I can say this ball is at equilibrium. Sorry, stable equilibrium. Stable equilibrium. And this ball, for this ball, I can
Unstable
say
equilibrium.
unstable equilibrium. And remember, this is a some surface. Okay, and this is ball, BALL ball. And there is another neutral equilibrium. So in neutral equilibrium, net force net force is zero. There is no problem. but body will be equilibrium at every point. At every point. Like you can see here is a surface. Here is a surface, and now here is a ball. Here is a ball. Okay, but there can be the confusion also. Here can be the confusion also. Now, if I am applying a force on this, means disturbing this, the position, this ball will come here, okay, and remain at the equilibrium, and again this ball will come here. After that, sometime, if I apply a force here also, then it will again come in equilibrium. So means here you can say the ball will be equilibrium when the wall will be equilibrium, when this ball is in equilibrium at every point. So you can say there is neutral equilibrium. Like you can say, I can say like this. Like this is pen. Okay, let's see. Are you getting now? Hello? Are you getting my
Yes, sir.
screen? Okay. Now this pen is in equilibrium, means at rest, no
Yes.
force. And suppose if I displace this pen from here to here. Now here also this pen is at equilibrium. Okay.
Yes.
So this kind of equilibrium means is a neutral equilibrium, means this, if I put the pen here. Okay. If I put the pen here, so it will not move. So, and if I am moving the pen here, it will not move. On the whole surface, the pen will not move. Means this is a condition of
Neutral equilibrium.
neutral. And now let's do one thing more. Suppose, hmm, suppose this is the surface like this. This is a surface like this. Okay, and if I am placing a pen here, okay, see the case of unstable equilibrium. If I am placing a pen here, what will happen? It will move like this and
Yes.
never regain its position.
So it's unstable.
Yeah, so it's unstable. And for the stable case, you can take this copy. You can take this copy as like this. Are you getting now?
Yes.
Suppose this is the stable. This is the stable position of this pen. Now,
Yes.
what is happening? This is a stable equilibrium. Now, if I am disturbing this pen from here to here, this will regain its position.
Yes.
So, means this is a case of.
Stable.
So, this is just I want to explain. Okay. And there is one more point that we should write here. Here is this is third point. No? Third point. This is the example. EG means example. This is third point. Third point is, in this case, potential energy is minimum. This is okay, na? Minimum.
Yes.
And third point is potential energy maximum. Maximum. And here potential energy constant. P means potential energy. Okay, please note it down. From here now?
Yes, sir. From types of equilibrium, I did that.
Okay, okay, okay. Are you getting na? I am whatever I am telling you,
Yes, sir.
uh,
So
or it's
these are still trial classes.
what?
Are these still trial classes?
I don't know.
I mean, because I remember on the first day, a teacher, I forgot the name, but like, yeah, she told me that there are like 14 days classes. And then I don't know, I remember that she told something is there for 14 days. So is that this? Because I'm confused.
I don't think this is a trial class.
Yeah, because like, yeah, that's what I was thinking because we're doing the portion.
Now this is not the trial. Actually, trial is for checking whether the teacher is good or not. Okay. So
Yeah, I was just like, I was confused. So that's why I was asking.
okay. No, no, please don't confuse.
So I wrote this.
You wrote this, and should I
Yes.
scroll down now?
Sir, from example.
So are you getting my points, or are my
Yes,
points
sir.
are getting out of your head?
Yes, sir. I understood.
Sure? Are you sure?
Yes, sir.
No problem. And if you have any doubt, now you can ask me. I'll always try to understand the things. Always. Not. I am not saying about the physics. It will be a bio also. It will be a because after all we are studying about the nature. Physics is something we are
Things around
studying.
us.
Yeah, physics, we are observing the things around us and we are studying those things and try to explain those things with the help of mathematics. This is all about physics. Okay, and after that we came to the board examination and competitive examination. Okay, so I will complete the syllabus accordingly as you are in CBSE. So we should have some questions of CBSE. How the we should understand the pattern of question of CBSE. Okay. On the
Yes, sir.
on Yeah.
And I'm also doing that. Our teacher did one chapter, and that might come in weekly test too. So she told us to do it properly in vacation. That is this one, magnetism and matter. And I was doing that only. I was like making notes and studying it.
Okay, fine, no problem.
Yes, sir. I completed.
So you completed. Okay.
Yes.
So you are from where?
So I'm from Rajasthan.
And currently you are in Rajasthan.
No. I'm in Qatar.
Okay, that's fine. So uh, uh, can I ask you two or three questions?
Yes, sir.
Okay. So please tell me what is charge?
Charge is an intrinsic property of a matter which allows it to experience a force when brought near other substance. I mean,
Very
other
good.
object or a body.
Oh, okay. And what is the unit of charge?
Colon.
Okay. What is the charge on a one electron?
Charge on one electron.
Hmm.
Okay. Yeah, I remember you said this. Charge on one coulomb is equal to
No problem. I am telling 1.6 into 10 to the power minus 19. Next
1.6
question.
into, yeah.
Next question is.
And they also ask these questions like what is one coulomb or 1 ampere. For that, there is like a sentence. You just
Yeah.
define the unit, like you put it in formula and just define it.
Yeah. We will do that in later classes. All the things, and I have not done for 1 coulomb. We will do for one for the electric field and potential. And one last question for you is like. Hmm, what is the formula of Coulomb's law when two charges are placed in air? Q1 and Q2.
Coulomb's law, Q1 in Q2 by 4 pi epsilon naught.
Please tell me the formula. What is the formula of force? Like here is a charge, here is a charge. This is Q1 and Q2, and I want to calculate the force between them. Then what will be the value of force?
It's gonna be K Q1
Yes.
Q2
Q1
by
Q2.
4 pi epsilon naught.
No. 4 pi r square. Actually, K is equal to 1 upon 4 pi epsilon naught. Don't confuse.
Oh yeah, you told this. I remember.
Okay,
There's
no
a value
problem.
of K also, 9 into 10 to the power 9.
Yeah, very good. So that's all for today, and please try to revise your notes. Okay,
Yes, sir.
means you have not got the assignment on the portal.
Are you asking the school one or from?
No, you are now I think in a tuition. Okay, so there is one portal of this company.
Oh, okay.
Have you understood now?
Yes, sir. Yes, sir. I'll check, sir.
Okay, fine. Okay, now you can leave, and thank you.
Thank you, sir.
Hello.
Hello.
Hello, Harsh. How are you?
Fine, sir. How are you?
I am fine. And give me just 2 minutes.
Yes, sir. Yes, sir.